Exercise 1.3. This is an application of productivity. This example, the input, which is $150, includes three components: labors for $30, materials for $70, and overhead for $50. The output is a sale for $300. We are going to do A, B, and C questions. However, I will show you only part A, and student may complete part B and C. Class A says to achieve a 10% multi-factor productivity improvement by reducing materials cost only, by what percentage must these costs be reduced? Okay, so in this question, we're gonna start by adding exercise. Okay, gonna enlarge it so it can be viewed easily. For this question, first we're gonna start out by multi-factor productivity. Okay, equal output divided by, in this case, labor plus material plus overhead. Okay, and in the current productivity equal 300 divided by 30 plus 70 plus 50 or about 300 divided by 150 or 2. Okay, we need 10% productivity improvement, which is about 1.1, which is 10%, times the current, which is 2.2. Okay, so in order to increase to 2.2, okay, the output stay the same at 300. Input must change. So the first one, we are going to maybe change the material first. Okay, the material is the second input in the formula. Okay, so we're gonna set up 2.2 equal, and on the right side, okay, we're gonna put 300, which is the output, divided by, in parentheses, of 30 plus, and we're going to put M to represent the material that we are going to find and change plus the 50. Okay, and as you can see based on this equation, okay, 2.2 will equivalent to 300 divided by, in parentheses of, 80 plus m. Okay, and then after that, okay, you're gonna try to solve for m. Okay, as you can see, when you solve for material, it's equivalent to about 56.36. Okay, so you can see that from 70 to 56.36, it's quite reduced. Okay, so you can see, you can find out percent reduction in materials equivalent to the original 70 minus 56.36. Okay, all together divided by the original times 100 become a percent. Okay, so which gonna equal 70 minus 36.96 0.36 all together about 19.48%. Okay, so that is going to be part A. So if you do the same thing, I encourage students to do so. Part B will get percent reduction in labor equal 16.36, and part C you will get percent reduction in overhead equal 20. Part B is about 45.47%. Part C about 27.27%. Okay, so I encourage students to do so. Now we finish exercise 1.3. Okay, on exercise 1.4, okay, we are going to go back to the slide of supplement A slide. Okay, on supplement A slide, when we open, okay, we call decision making. The first one of the decision making is break-even analysis. On the break-even analysis, okay, break-even analysis will find out the break-even point. Break-even point is a point at which the profit equivalent to the cost. Okay, and there are many uses of the break-even analysis. Like for example, to use to predict the sale volume, or break-even analysis can use to predict the variable cost. Can be used to find how much is the fixed cost, or to find out the sale price also. Okay. in break-even analysis, there are two costs that we are interested. The first cost we call variable cost. We use C to represent variable cost. Variable cost, okay, is the cost that varies related to the quantity of product we produce or the quantity of the item we sell. Okay, the more we produce, the higher the cost will be. If we don't produce or sell, variable cost will be 0. Okay, and total variable cost will directly related to the quantity. So the variable cost is C times Q. Fixed cost is the cost that's not related to the volume. It is the cost that stay put. Sometimes we can also call this some type of administrative cost, or sometimes we call it setup cost. Okay, as you can see that break-even point is the point where total revenue equal total cost. Total revenue equivalent to P times Q. P is the sale price. Total cost includes fixed cost plus variable cost, or F plus C times Q. You can see that break-even point equal F divided by P minus C. Okay, as you can see that based on this example, break-even point can be found by using two approaches. First approach we call algebraic approach, which we use mathematical formula. Like in this example, if we have fixed cost of 100,000 divided by P minus C, which is 200 minus 100, you will get of a break-even point of 1,000. Or you can also solve the break-even point by using a graphic approach. In a graphic approach, the break-even point is the product of two lines. The first line is the total cost line, which is the fixed cost plus variable cost, or 100,000 plus 100 times Q. Okay, and also another line is the revenue line, which is P times Q, 200 times Q. Okay, in order to make each line, you need two dots. Okay, one dot must be at the quantity of something lower than a break-even point. The recommended value is 0. And then another point is the point where the quantity go beyond break-even point. In this particular example, if break-even point is 1,000, then 2,000 is a good point. And then once you plug in the quantity in the formula, you will get that to draw two lines. The red line represents the total cost line. You can see total cost does not meet 0. Total cost must start at the fixed cost at minimum. The red line represents total cost. The blue line represents revenue, which go to 0 when you produce no product, or in this case you have no customer. Okay, when the two lines meet, the point at $200,000 we call the break-even cost. and that point we also call break even break even point at Q equal 1000. As you can see that the points above break even point with in the blue gray area we call the profit area, which total revenue is more than total cost. The point below break even point we call a loss area, which is the area when the cost is more than the revenue. Okay, so on example 4 that we are going to do, we are going to experiment on the Mary William company, and this company has fixed cost of 60,000, have a variable cost of $6, and have a sale price of $18. For this example, we are going to go to Excel. Okay, for this example, first we're gonna try to find by using the algebraic approach. Okay, so we have fixed cost F equal of 60,000, variable cost of $6, and sale price of $18. So we have a break-even point of equivalent to 60,000 divided by, in parentheses of, P minus C. Okay, 50,000 units. Now, next, we are going to use, we call graphic approach. Okay, on the graphic approach, we will have two lines. So we're going to set up first. Okay, we're going to go back to the slide and try to set up the same way, like over here. First column we're going to set up as Q. Second column we're going to set up as total revenue. And the third column we're going to set up as total cost. So the first column we're going to set up as Q, quantity. And we're going to set up total revenue as the second column, and total cost as the third column. Okay, for total revenue, okay, we're going to set up as P times Q. Okay, for total cost, we're going to set up as F plus C times Q, like that. Okay, now let's set up the formula. Total revenue equal, okay, sale price $18 times Q, or total cost equivalent to fixed cost 60,000, okay, plus C times Q, 6 times Q. Okay, now once we have the formula, then we can identify 2 points. The first point recommended is 0. Second point should be something, let's put that break-even point. Okay, it should be something beyond 5,000. 10,000 is good. Okay, so first we're gonna take $18 times Q. 0 will be 0. And the second one will be 60,000 plus 6 times 0 will be 6,000. Okay, now next we are going to find the at 10,000 units. For total revenue will be 18 times 10,000, which is 180,000. Total cost will be 60,000 plus 6 times 10,000, which is 120,000. Okay, and then with this, we're gonna have to find the chart. To follow, so please make sure you open it or so we are going to trying to draw a chart. In this chart, we'll have the total cost as a y-axis of each with the $1,000 unit from 0 to 180,000, and the x-axis is going to be the quantity. Okay, as you can see that at 0 unit, the total revenue is 0, and at 10,000 quantity, total revenue is 180,000. So we're going to try to draw a line. Okay, from 0 to 180,000. Okay, let's give it like a yellow. We call that total revenue line. Okay, then next you can try to draw the total cost line, which I'm going to insert shape. Okay, so we're going to start out with 60,000. Okay, and end with 120,000. $20, $40, $60. I think that it's a little bit higher than. Okay, so you can see that from this point, let's give it like a maybe blue. We call total cost line. Okay, as you can see that the break-even point is middle between the two. So break-even point is over here. Okay, which about 5,000 units. Okay, so that's two approach you can do, or sometimes you can also highlight total revenue in orange, total cost is in the blue, so you know. Okay, now with these two approach, okay, we complete part A. Okay, for part B, question asks, okay, if the current quantity is 10,000, and the selling price is set to $14, what should be the contribution profit? Okay, the contribution profit is equivalent to the difference between the total revenue minus the total cost over here. So contribution profit, or in short, profit, equal total revenue minus total cost, or P times Q minus, in parentheses of, fixed cost plus C times Q. Okay, so in this example, total profit of this example will be equal total revenue, which is 14 times 10,000, minus in parentheses of fixed cost, which is 60,000, plus C $6 times Q, which is 10,000. which you will find out that the total revenue is about $20,000. Okay, next part C asks, okay, if the if the selling price is set to $12.5 and the new volume is increased to 15,000, which strategy is better? So we're going to set up another queue of 15,000 and the sale price of 12.5. Okay, so we're going to try to find profit the same way like we did. Equal maybe 12.5, okay, times 12.5 times 15,000 minus because plus C times Q. Okay, and based on the calculation, let's put equal in there so we know that not the calculation. So we will find out that the profit is 37,500. Okay, you can see that we can summarize that at sale price P equal 12.5, the profit is better. Okay, I think that is the finished exercise 1.4. Okay, student may try exercise 1.5 and 6 by themselves, and the exercise 1.5 and 1.6 is just to use algebraic approach, like this example. Let me show you. Like this example, okay, if the number of, okay, so these are example of how to find contribution. Okay, when you have 15,000 patients, okay, you take revenue minus total cost and you will get the total contribution or the profit. Okay, for 1.5 and 1.6, we call this sensitivity analysis. Sensitivity analysis is analysis when you are trying to change the variable in order to achieve different outcome. Okay, and then I hope you I hope students try this. Okay, next concept we are going to study is also the same. This is the application of the break-even analysis. We call two processes analysis, or sometimes we can also call make or buy decision. Okay, in this analysis, we're gonna use break-even theory. Okay, if we use M to denote make decision and B to denote buy decision, okay, if we want to compare whether or not to make or buy, we set up these two equations to be the same amount. Okay, by assuming that the sale price stay the same. Okay, you can see that break-even point will be Fm minus Fb divided by Cb minus Cm. Okay, and with this approach, okay, we're gonna experiment on example 1.7. On example 1.7, you can see that these are the magazine organization. Okay, and this magazine organization is trying to move to modernize the process. In order to modernize the process, the organization must use computer-like system. Okay, when using computer-like system, the fixed cost will be increased because the organization must invest into the system. So the fixed cost increased from 400,000 to 1.3 million. On the other hand, when you move to modernized process, the variable cost will decrease from 6.2 to $2.5. So question asks, at what point the modernized system will be more attractive? So we're going to use a break-even analysis. So we're going to go to exercise number exercise 1.7. On exercise 1.7, we're going to enlarge it. So we call make or buy decision. Okay, and Q equivalent to FM minus FB divided by CB minus CM. Okay, for this example, when you make, meaning you are doing computer-like system, a fixed cost FM equivalent by okay, and then the variable cost is $2.25. Okay, when you buy, in this case, you use a manual system. FB will be 200,000 and CB will be $6.2. Okay, so the break-even point is gonna be, you put parentheses, don't forget tab, FM minus FB divided by CB minus CM. Okay, about 227,848 units. Okay, and question B, question 2 asks, if right now the volume is 225,000 and okay, the company would like to go ahead and invest in modernize. By investing into modernize, they will increase the volume to 900,000 and they can also they are able to reduce the price from $8 to $4. So the question asks which one is better. Should we modernize the system? So in order to answer the question, we must find out the profit. Okay, so part B. Okay, we have two situations. One is the modernize, which you're gonna have key volume of 900,000 and the sale price of $4, and the variable cost of modernize is 2.25, and the fixed cost of modernize is 1.3 million. Okay, so we're gonna find out the profit of this approach, which equal P times Q minus fixed cost plus C times Q. Okay, so we're gonna find out that P is $4 times Q, which is 900,000, sorry. Okay, minus in parentheses of fixed cost is 1.3 million plus C, which is 2.25 times 900. Okay, so the modernized system will have profits of 275,000. Okay, when you do manual system, let me reduce that. When you manual system, the quantity that you can serve is about 225,000. The sale price will be $8. Variable cost will be 6.2, and the fixed cost will be 400,000. Okay, so profit will be first you take P $8 times 225,000 minus in parentheses of 400,000 plus 6.2 times 225,000, like $500. As you can see that the modernized has higher profit than the manual. Okay, so for question B, we can summarize that the clipping service should be modernized because of the higher contribution profit. Okay, now on this question also asks on part C that if the forecast increase in business, if the forecast if the forecast increase in business is too optimistic, at what volume will the process break even? So in this example, we are interested in only the new process. So break even point equal F divided by P minus C. Okay, so the bottom line fixed cost is 1.3 million divided by the $4 divide minus 2.5. Okay, so the break even is about 742,857 units. Okay, so that finish exercise number 1.7.